So halo words, right? It's made from halo plus alkane word. So halo means halo comes from halogen, right? We know that what are halogen groups. So it's fluorine, chlorine, bromine, and iodine, right? Basically, group 17 elements, they are known as halogen groups, okay, which is denoted by X, right? And haloalkane. So basically, it is substituted product of alkane by halogen. Okay, when we know that what is alkane, so basically alkane is hydrocarbon part, right? So its formula is alkane. Just a second. Alkane. What is the general formula of alkane? It's CnH2n plus 2, right? So when you just replace one hydrogen from alkane by any halogen group, by any halogen, then you will get haloalkane. Okay. So basically, uh, haloalkanes are obtained by the replacement of hydrogen atom of an alkane by halogen group. Okay. For example, if I take methane, it's CH4, right? If I replace one hydrogen from here, right, by your halogen group, right? If I replace the hydrogen group by halogen group, so it will give you this compound is known as your haloalkane. Haloalkane. Got it? So basically, we can say that haloalkanes are substituted product of alkane by halogen. When you replace one hydrogen by a halogen group, so you will get a haloalkane. Got it?
Yes, ma'am.
And yeah, what about the haloarenes? So halo, similar means halogen group, and arenes. Arenes come from the aromatic compound, right? You know what is aromatic compound?
Yes, ma'am.
Yeah, tell me what are aromatic compounds?
The benzene ring.
Yeah, basically that type of compound in which conjugated double and single bond is there. Means alternate double and single bond जिसमें होगा, that is known as your aromatic compound. Okay, means your delocalized pi system, delocalized pi electron. So it is known as aromatic system. Like just like a benzene. Benzene ring is the best example of your aromatic system. You can see over here the alternative single and double bond. Right here the single bond is there, then double bond, then single, then double bond. So it is known as conjugated system. Right? Single and double alternative bond. So this is your aromatic ring. And aromatic compound are also known as aryl compound, or you can say arene. They are known as arenes. Okay. So the aromatic compounds are also known as arenes. So if I take any arene, aromatic compound, just like your benzene, okay. So everywhere is hydrogen, one hydrogen. So if I just remove one hydrogen from here, right, and this hydrogen is replaced by any halogen group, any halogen atom. Suppose X, right? X can be your fluorine, chlorine, bromine, iodine. So this group is known as your haloarene. This is known as your haloarene. Got it?
Yes, ma'am.
Yeah. So basically, this chapter is all about haloalkane and haloarenes. We will see the its nomenclature, its methods of preparation, chemical properties, right, etc., physical properties. Everything we will learn in this chapter. Okay. Okay. See the topic. It's a classification of haloalkanes and haloarenes. Yeah. So basically, haloalkane and haloarenes, they are classified on the basis of number of halogen atom, right? Number of your halogen atom. Suppose if there are only one halogen atom in your compound, right? If there is only one halogen atom, then it is known as monohaloalkane. Or if it is a haloarene, then We will say that it is monohaloarene. Monohaloarene. If it is one, if there is only one halogen atom, right? It could be your fluorine, chlorine, bromine, iodine, right? Second one, this is your first type. Second type is when there are two halogen atoms, right? If two halogen atom is present, then it is known as dihaloalkane or dihaloarene. Got it? And this two halogen could be of same halogen group or either different. Whether it could be fluorine, fluorine, it could be your or either it could be fluorine or bromine or fluorine or iodine. Okay, so similar halogen group भी हो सकते हैं and different halogen group भी हो सकते हैं. So if there are two halogen atom, then it is known as dihaloalkane. Okay, or if it is haloarene, then it is known as dihaloarene. Got it, Muniba?
Yes, ma'am.
Yes. Okay. Third one. If there are three halogen atoms, okay, in any compound, so it is known as trihaloalkane or trihaloarenes. Okay, let's see. You understand the concept or not? See this. So we have to classify the following on the basis of number of halogen atoms. Okay, so see first one. Tell me the first one.
Bromobenzene.
No, I think your voice is not audible. It's breaking. Is your internet connection is stable, Muniba? Just check it. Yeah, Muniba, just tell me. Just tell me whether it is monohaloalkane, monohaloarene, or dihaloalkane. Which one is this?
Okay. It's monohaloarene.
Haloarene, are you sure? Check it if it is arene or not. I just told you what is arene. Arene is aromatic compound in which conjugated, it's only cyclopentane, right? So it's again an alkane group. Alkane can be your open chain भी हो सकता है, your cyclic structure भी हो सकता है, right? So it's an alkane, not arene, right? So it's mono because only one halogen group is there. So it's mono halo alkane, not haloarene. Okay, got it, Monima? Okay, second one.
Dihaloarene.
Yeah, it's dihaloarene. Yeah, it's arene, right? You can see the benzene structure over here. So it's arene. So it's dihaloarene. Third one,
Trihaloalkane.
yeah, trihaloalkane. Very good. Fourth one,
Dialkane.
yeah, dihaloalkane. This is trihaloalkane. Last one,
Dihaloarene.
dihaloarene. Okay, now it is clear.
Yes, ma'am.
Okay, so write it down till here. Yeah, from the starting. Okay, just write it down. Then we will jump to the next concept. Can I scroll down?
Yes, ma'am.
Written, Munira?
One line, ma'am.
Okay.
Done, ma'am.
Okay, monohaloalkane, they are basically classified in two parts. Okay. And yeah, just remember haloalkanes can also be are also known as alkyl halide. Okay, alkyl halide for haloalkane and aryl halide for the haloarenes, right? So that's another name for these two. Yeah, so just this topic, it's very important to remember what are the alkyl halides, what are vinylic halides. So I will explain it to you. Monohaloalkanes, they are basically classified in two parts. If first is if the halogen group is directly attached to sp3 hybridized carbon, right? If the halogen group is attached to sp3 hybridized carbon. Okay, so accordingly, there are different classification of halides. Second type is if the halogen group is directly attached to sp2 hybridized carbon. Okay, so accordingly, there are two types of halides, vinylic halide and aryl halide. Okay, so let's see one by one. First, so when the halogen group is attached to sp3 hybridized carbon, okay, so first type is your alkyl halide. Okay, so what is alkyl halides? When the your halogen group is directly attached to your P3 hybridized carbon. So it is known as your alkyl halide. See, in this case, the fluorine, it is attached to this carbon, right? And this carbon is, what is the hybridization state of this carbon, Muniba? You can draw the open structure also. CH3, CH2, CH2, and F, right? So this fluorine is attached to this carbon and this carbon is sp3 hybridized, right? This is carbon is sp3 hybridized. So it is known as your alkyl halide, right? Clear or not?
Yeah.
And how to decide whether it's primary, secondary, or tertiary? So see, this halogen group is attached to this carbon, right? And this carbon is further attached to only one group, right? This carbon is further attached to only one group. So this is your primary alkyl halide. Primary alkyl halide. If I give you another example, like an example, okay, uh, you just have to tell me which alkyl halide is this, primary, secondary, or tertiary. Yeah. See the second one. Which alkyl halide is this? See, this bromine is attached to this carbon, right? And this carbon is further attached to two groups, right? This CH3 group here and CH3 group here. So this is your secondary alkyl halide. This is your secondary alkyl halide. Got it, Muniba?
Yes, ma'am.
Third one, just tell me the third one.
Primary.
No, it's not primary. You just have to check this halogen group. This is attached to this carbon, right? And this carbon is further has two groups. यहाँ से भी इस साइड से भी attached है, right? CH2 group from here and यहाँ से भी CH2 group, right? So basically there are two groups which is attached to this carbon, right? So this is your secondary one. If it is having a primary अगर होता तो इससे सिर्फ one attachment होती, right? Only one group attached to this carbon. But here the two you can see here there are two groups, right? One bond from here and one is bonding from here. So this is again a secondary alkyl. Got it?
Yes, ma'am.
Yeah. And because this chlorine is directly attached to sp3 hybridized carbon, so it is your alkyl halide. Now, why secondary? I just explained it. This one, see this structure? This carbon is further attached to the CH3 group, CH3 again, here CH3, right? So this bromine, uh, your halogen group is attached to this carbon, and this carbon is further attached to three groups, three methyl groups. So which alkyl halide is this, Muniba?
Tertiary.
Yeah, it's tertiary. Very good. It's tertiary. alkyl halide. Now it's clear how to find whether it's for primary, secondary, or tertiary. You just have to check the halogen group. Just see the halogen group and which carbon to which carbon the halogen group is attached. Okay, and you just have to check that carbon has how many groups attached to it. Okay, if only one group is attached to it, with that carbon, so it is primary one. Okay, if the two groups are attached, right? If there are two groups, so it is secondary one, and if there are three groups attached to that carbon, then it is known as tertiary. Got it?
Yes, ma'am.
Yeah. Second one. Okay, again, this is a type of halogen which when it is attached directly, halogen is directly attached to sp3 hybridized carbon. So it is a type of that. Second type is allylic haloalkane. Allylic haloalkane. Or you can say allylic alkyl halide. Okay, so in this case, halogen is connected to sp3 hybridized carbon. We know that. Okay, because C का type है. So halogen is directly attached to sp3 hybridized carbon. And this sp3 hybridized carbon is further attached to sp2 hybridized carbon. Okay? sp2 hybridized carbon means further आपको पहले क्या देखना है? पहले आपको देखना है this halogen group. This halogen group is attached to sp3 hybridized carbon. Okay, if it is attached to sp3 hybridized carbon, so further आपको देखना है further whether it's attached to sp2 hybridized carbon or not. Means यहाँ पे carbon carbon double bond present, right? I will give you some example. For example, let's take CH2, CH, CH2, and here bromine group. Now see this. This is your halogen group, right? This is attached to this carbon, right? And this carbon is, see, this carbon is sp3 hybridized, right? Why it is sp3 hybridized? Because there are 4 sigma bond, right? Just remember in sp3 hybridized carbon, 4 sigma bond is there, right? 4 sigma bond means 4 single bond. If it is sp2, then 3 sigma bond. Okay, if it is sp, then 3 sigma bond, 3 single bond. Okay, so 2 single bond. Okay, so accordingly, you can just find out which hybridization is this. So here you can see that there are 2 for this hydrogen and 2 for this bond, right? So again, this is your sp3 hybridized carbon. Okay, and this sp3 hybridized carbon is further attached to this. You can see carbon, double bond carbon. Means this is your sp2 hybridized carbon. Okay, see the pattern. This halogen group is attached to sp3 hybridized. Then further this sp3 hybridized carbon is attached to sp2 hybridized carbon. Okay, means if certain molecule, if certain compound follows this sequence, so it is known as allylic haloalkane or allylic alkyl halide. Got it?
Yes, ma'am.
Okay. Okay, I will give you another example. Just check it. Which halide is this? Which halide is this?
Secondary.
No, not secondary. Means your this is your allyl halide, benzyl halide. Which one? And give me the reason also. Which type of halide? Not secondary, tertiary. मैंने पूछी. Which type of halide is this?
Allylic.
Yes, it's allylic. Very good. Why it is allylic, Muniva?
Because after an sp3 bond, there's an sp2 bond. Like the halogen is
Yeah,
attached to the sp3 carbon.
yeah. Very good. Yeah, you just have to see this halogen group. This chlorine group is attached to this, right? And this is your sp3 hybridized carbon. And this sp3 hybridized carbon is further attached to this carbon-carbon double bond, means your sp2 hybridized carbon, right? So you just see this pattern. Yeah, this sequence is visible here. So this is your allylic haloalkane. Yeah, clear?
Yes,
Yeah.
ma'am.
Next one is your benzylic halide or your benzylic haloalkane. Yeah. So in this case, in benzylic type of case, basically the halogen group is attached to sp3 hybridized carbon, and further that sp3 hybridized carbon is attached to benzene ring, right? For example, first write down the definition. So here the halogen is connected to sp3 carbon, which is further connected to benzene ring. Yeah. For example, if, yeah, first write down the general structure. This halogen group is attached to sp3 hybridized carbon, and this sp3 hybridized carbon is further attached to the benzene ring. Okay, so this type of pattern you will see in the benzylic type of halide. For example, I'm writing here, this is benzene ring. Yeah, so here this is your CH2 and Br. Okay, so see this. This is an example of benzylic halide. You can see over here. So this is halogen group. Halogen group is attached to your sp3 hybridized carbon, and this sp3 hybridized carbon is further attached to benzene ring, right? So this is an example of benzylic halide. Clear, Muniba?
Yes,
So
ma'am.
these are the three types of of this, right? When the halogen is directly attached to sp3 hybridized carbon. Second one, first understand the concept, then I will give you time to note down. Okay, second one is your when the halogen group is attached to sp2 hybridized carbon, right? So there are two types. First one is your vinylic halide, right? So vinylic halide is those type of halide in which the halogen atom is directly connected to carbon-carbon double bond. Okay, and we know that carbon-carbon double bond is sp2 carbon, sp2 hybridized carbon. Okay, so basically X is directly attached to sp2 hybridized carbon in this case. For example, CH2 double bond CH, and here bromine. Yeah, see here. So this is a bromine, right? Halogen group is attached to carbon-carbon double bond, right? So this is your sp2 hybridized carbon. So direct attachment is there. Okay, another example. Suppose so. I'm just drawing it over here. It is cyclopentane, and here there is a double bond, and here fluorine group is attached. Now see this. Again, this is your this chlorine, right? Halogen group is directly attached to this carbon, means your carbon-carbon double bond. Here you can see carbon-carbon double bond. Means this is your sp2 hybridized carbon. So this is your vinylic halide. Okay, so this type of halide is known as vinylic halide, in which you can see the direct attachment of your halogen to the direct sp2 hybridized carbon. Okay, when the sp2 hybridized carbon is directly attached to your halogen group, then this type of halide is known as vinylic halide. Got it, Munirma?
Yes, ma'am.
Okay, next one, your aryl halide. Yeah. So aryl halide means your haloarenes. So you know very well what are aryl halides. So basically, when the halogen group is directly attached to your benzene ring, when halogen is directly attached to benzene ring. This is known as aryl halide. Okay. For example, this benzene ring is this, and the halogen is directly attached here. So this is your aryl type of halide. Let's write down the example. If I give you this bromine group here, so bromine group, bromine is directly attached to this benzene, so it is known as aryl halide. Yeah. Second example, if I draw the toluene, what is toluene? You know what is toluene, Muniba? If the methyl group is attached to the benzene ring, right? This is your toluene. Okay. If I add fluorine here, right? So this is your aryl halide because you can see the fluorine is directly attached to this benzene ring. So this is your aryl halide. Okay, now just tell me, is it clear? Everything is clear till now?
Yes, ma'am.
And yeah, just remember, sometimes the students got confused in between aryl halide and benzylic halide, right? So in benzylic halide, in in aryl halide, see, the halogen has direct attachment to the benzene ring, right? Halogen just directly connected to the benzene ring. But in the case of benzylic halide, the halogen is first connected to sp3 hybridized carbon. Then this sp3 hybridized carbon is attached to the benzene ring. Okay, so this is the difference between your aryl halide and this is your benzylic halide. Benzylic halide. Okay, so just remember the difference in between these. Yeah, sometimes students thought this is a benzylic halide, so the halogen group must attach directly to the benzene ring. But that's wrong, right? But here in the benzylic halide, the halogen group is first attached to the sp3 hybridized carbon, and after that, it is attached to the benzene ring. Okay? Okay, now you can write it from here. After that, we will discuss some questions based on this.
Ma'am, can you scroll down? Ma'am, can you? Ma'am, can you scroll down? Done, ma'am.
Okay. So here's a question. Name the following halides and classify them as alkyl, allyl, benzyl, vinyl, or aryl halide. Okay. So this is a question. 5 questions are there. First, try to just draw the structure. Okay. After that, just classify, just name that following that halide and classify them as this one, right? Alkyl, whether it's alkyl, allyl, benzyl, etc. Yeah, I have explained it to you. What are these terms? Okay, let's see one by one. First question. So it's, okay, let's try to write down the structure first. I'm just starting from the right side. So it's CH3, right? After CH3, this is CH, right? CH, and on CH, the chlorine is attached. Again, CH group, and here there are two attachments over there, CH3. So it's CH3, and again here's a CH. Okay, so that's the structure for the first. Now try to name this compound. Okay, so how to name? So just try to find the longest chain first. Right, so this is the longest chain, and आपको ऐसे find करना है so that the functional group will have the lowest number. Will get the lowest number. So 1, 2, 3, and 4. Right? Now write down the name. Yeah. So it's 2-chloro 2 chloro, 3 methyl, and there are 4 carbons, so it's butane. Okay, and which type of alkyl halide is this? Which type of alkyl halide is this? So it's, yeah, you can see over here, this is alkyl halide, right? The chlorine is directly attached to sp3 hybridized carbon, right? And this sp3 hybridized carbon, so it is your alkyl halide. And just check it, which type of alkyl halide, whether it's primary, secondary, or tertiary. Yes, Moniba, tell me, which alkyl halide is this? Yeah,
Primary.
it's, no, bache, I just told you, na?
Secondary, sorry, sorry.
Yeah, it's secondary. See this halogen group, this is attached to this carbon, and this carbon is attached to these two methyl group here, and this is CH3, CH group, right? So there are two groups which are attached to this carbon. So it is secondary. It is secondary alkyl halide. Okay, got it? So just do the rest, second, third, fourth, and fifth. Okay, first try to draw the structure. After after that, just try to name that a structure. Okay, and just after that, classify them accordingly. Yeah, just take your time and do that. Done, Muniba?
No, ma'am, 1 minute.
Okay, okay. Completed, Muniba?
Ma'am, what's the last one? It's PCL.
P is your para position. Ortho,
Okay.
meta, para, right? So it's para. Yeah, so basically it's a benzene ring, right? So this is your C6H, right? So here the benzene ring is there. And at para position, there is a chlorine group. If I just add chlorine here, so according to this will be your para position, right? If you are just substituting this group here, right? So according to this, so this is your para position. So para पे आप attach कर दो chlorine group, and here this is your CH2 group, there CH group, and here on the CH group there are two substitutions, CH3, and again this is the structure. Okay, now try to now name this structure, right? So I'm just starting from here. This is 1, 2, 3, 4, right? 5, 6, 5, 6, right? And this is another substitution here, right? So this is your 1 dash. You can write 1 dash for this. This is your 2 dash, right? And this is your 3 dash. Okay, अगर इसे आप straight chain ले रहे हो, this is a straight chain. So this will act as a substitution. This methyl group will act as a substitution. So let's name this. So it will be 1 chloro, right? This is your main parent chain, right? Parent is your benzene. 1 chloro, and at the fourth position, right? 4, right? And on the fourth position, there is a substitution over here. So you will write in bracket. So it will be, this is your 3 carbon, right? So for 3 carbon, it is propyl group, right? It's propyl, prop. And on the second carbon, 2 dash, right? On the second carbon, there is a methyl group attached. So you will write down the position also. So it's 2 methyl propyl, 2 methyl propyl. And what is the parent chain? So it's benzene, right? So the name of this is 1 chloro 4 2 methyl propyl benzene. Clear, Muniba? Now tell me, which type of halide is this?
Yes.
Which type of halide is this?
Aryl halide.
Yeah, it's aryl halide. Okay, so you just have to see the halogen group. So halogen group is directly attached to this, your benzene ring. So it's aryl halide. Aryl halide. Okay. Now tell me about these fourth, third, and second. For the second one, okay, I'm just drawing one by one the structure and name. Just check it whether you have done it correctly or not. Okay,
Already.
for the, yeah, so let's draw the structure first. So it's CH3, CH2, right? CH, on CH there is a substitution. CH3, right? Again CH here, right? And this is a substitution over here. This is, you can also, you can also write C2H5 as a open chain. इसको आप CH2 CH3 भी लिख सकते हो, CH2 CH3, right? And you can add chlorine here, right? Now what we have learned, we have to just check out for the longest chain. So this is your longest chain, 1 2 3 4 5 6, right? If we take 1 2 3 4, this will be 4 only if we take this ring. So I'm just taking this ring, this chain. This is the longest chain. So 1 2 3 4 5 6. Okay, if I give the name from here, so it will be 1 2 3, right? So chlorine को आपका third position मिलेगा, right? Chlorine will get the third position, but from here 1 2 3 4, right? So it will get fourth position, right? But हमारा motive क्या है? हमें जो हमारा functional group है like chlorine, so इसे हमें lowest number देना, right? So we will start from here. 1 2 3 4 5 6. Now write down the name of this. So it is 3 chloro, 3 chloro, right? On the fourth position, there is a methyl group, 4 methyl right? And there are six carbons, so it's hexane. So it's hexane. Got it, Muniba? Is it correct? आपने same इसी तरह किया है?
Yes, ma'am.
Okay. Now, what is the name of this halide?
Alkyl
Yeah. Which type
halide.
of alkyl halide? Yeah. Which type of alkyl halide? Primary, secondary, or tertiary? Let's just check it. This halogen group is attached to this carbon.
Secondary.
This, yeah, very good. This carbon is further attached to two groups, CH2 and CH. This is your secondary alkyl halide. Okay, so that's how to write down the name, draw the structure, and classification based on the your halogen. Third one. Okay, you want to tell me the answer for the third one? Tell me the name.
It's alkyl halide. 1-iodo 2,2 dimethyl butane.
Yeah, very good. It's 1-iodo 2,2 dimethyl butane. Yeah, yeah. So if you draw the structure, so it will be your so CH3 here, CH2 here, carbon and carbon पे दो substitution है methyl group CH3 and CH2 and I. Right. So this is the structure. Now just tell me which type of halide is this?
Alkyl halide.
Yeah. The primary, secondary, or tertiary?
Primary.
Yeah, very good. That's primary and primary. Okay. Let's see the fourth one. First write down this. It's quite messy. Write down this, then we will see the fourth one.
Uh, Done, ma'am.
Yeah, done?
Yeah.
Okay. 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 I'm writing here. Question number, it's third or fourth? I think third. No, it's fourth. Okay, see. So let's draw the structure. It's CH3, CH. I'm just directly drawing the structure. Yeah. CH3, CH, and here the double bond is there, carbon, and on carbon there is a substitution, fluorine, CH2, CH, again there are two substitutions, CH3 and CH. Yeah, now just find out the longest chain first, and you should keep in mind that this double bond and this chlorine group, right, this substitution, this will get the lowest number, right? So when you start from here, 1 2 3 4, right, so this chlorine will get fourth position, and this carbon also, this double bond also gets fourth position, so 4 4. But when you start from here, from the left side, so it will 1 2 1 2, the double bond will get second position, and this chlorine will get third position. So it's 2 comma 3, right? But from the right side, it's 4 comma 4, right? So we will take this 2 3, right? 2 comma 3 is the lowest number, so we will take that. So we will start from here. 1, this is the longest chain, right? 1 2 3 4 5 and 6. Okay. Now see, on the second carbon, there is a double bond. On the third position, it's a chlorine group. So 3 chloro, right? On the fifth position, there is a methyl group. So it's 5 methyl. Yeah. So how many carbons are there? 6 carbons. So it's hex, right? And at the second position, सेकेंड एंड थ्री के बीच में डबल बॉन्ड है, सो वी विल राइट 2 ene. Yeah, so that's the IUPAC name of this structure, right? 3-chloro 5-methyl hex 2-ene, right? Now tell me which type of halide is this?
Vinylic.
Yeah, very good. Yeah, so this chlorine is attached to this sp2 hybridized carbon directly. So it is your vinyl. Is vinyl halide. Now got it?
Yes, ma'am.
Everything is clear from today's concept?
Mm.
Okay, so I will give you homework based on this. Right, nomenclature पे मैं homework दूंगी, like write down the IUPAC name of this structure, to classify the which type of halide is this. Right, so this type of homework I will give you, and just try to do that homework and submit it as soon as possible. Okay, before the next class.
All right, ma'am.
Okay, so now that's all for today. I'm not going to start the new topic. Okay, so basically 5 minutes are less, so let's discuss some the nomenclature also, right? So because we have done the nomenclature, so let's see what are these, how to name. So basically, uh, nomenclature. So basically, in common system, there are two systems. Like common system में हम कैसे name करते हैं, and in the IUPAC system, how to name the compound. Okay, so IUPAC name we just saw that. Okay, we just discussed and we just practice some questions also. Now see in the common system, what we have to do. So basically, you just have to add word halide, right? You just have to add the word halide to the name of the corresponding alkyl. Okay, आपको ये halide आपको use करना होगा. For example, yeah, just a second. Basically, alkyl halides means your haloalkane. They are named by adding the word halide to the name of the corresponding alkyl group, right? And we use the suffix, we use a prefix n for normal. If the structure is normal, like a normal pentane, so you will use n pentane, right? If it is iso structure, okay, isoform mein hai, so you will use iso. If it is secondary, so you will use sec. If it is tertiary, so you will use third in the common name, right? But IUPAC name में ऐसा कुछ नहीं होता है, right? So in the IUPAC name, basically alkyl halides are named as halo substituted hydrocarbon. That is a haloalkane. Okay, and we have to just write down the prefix word which is halo, like your chloro, bromo, right? हम आप chloro, bromo means your halo word we just use as a prefix, right? But in this, in the common system, we just use halide, right? Alkyl group के साथ हम halide use करते हैं last. Let's see. Let's see some questions. Yeah, see this question. CH3, CH2, CH2Br, right? So in common, what is the common name of this and what is the IUPAC name of this? Let's see. IUPAC, no, you know very well how to write down the IUPAC name. But this is how to write down the common name. So you can see this is a normal chain, normal open structure, open chain. So for normal, we use N. And what is this? There are 3 carbon, right? So for 3 carbon, we use prop word. So it's N propyl. And after this alkyl group, when we just write down the name of this alkyl group, तो उसके बाद हम क्या करते हैं? Halide use करते हैं. Like if it is bromide, so we will use here for N propyl bromide. N propyl bromide. Now let's see what is the IUPAC name of this. Yes, Muniba, tell me what is the IUPAC name of this?
Bromopropane.
Yeah, it's 1-bromopropane. Yeah, it's compulsory to just write down the position of that halogen atom, right? So you will add 1-bromopropane. Okay. Second one, just tell me the common name and IUPAC name of this.
Secondary propyl chloride.
Secondary propyl chloride. It's iso. is the isopropyl chloride. It's isopropyl chloride, right? And what is the IUPAC name of this?
2-chloropropane.
Yeah, very good. So 2-chloropropane. Okay, so that's how we just give the common name and IUPAC name. So clear? So we have
Yes, ma'am.
discussed. Yeah. So I will give you homework based on this. Okay, so just try to submit the homework as soon as possible. Okay, Moniba, so that's all for today. Is there any doubt in today's session?
No, ma'am.
Everything is clear.